Welcome to Chapter 2, Lesson 5, which goes over multiplying decimals. The standard that we're working on here is being able to fluently add, subtract, multiply, and divide multi-digit decimals using the standard logarithm for each operation. The key idea here for multiplying decimals is very important, so make sure that you highlight this. When multiplying decimals by whole numbers, multiply as you would with whole numbers. Then count the number of digits behind the decimal in your problem. Place the decimal in your answer so that it has the same number of digits behind the decimal. Let's do a couple examples so you can see what that means. So when we're multiplying decimals and whole numbers, we have 6 times 3 and 91 hundredths. So we're going to multiply just like we would with whole numbers. You do not need to line up decimals. I repeat, you do not need to line up your decimals when you multiply. So we're going to count the digits behind the decimal in your problem and see that there are 2. So in our final answer, there will be 2 digits behind it. All right, so let's pretend like this decimal is not here. So we have 6 times 391. Well, we would put 391 times 6, like so, and we're going to multiply like normal. 6 times 1 is 6. 6 times 9 is 54. Carry your 5. 6 times 3 is 18. Plus 5 is 23. Now remember, we had 1, 2 places behind our decimal. So we're going to have 1, 2. 2 numbers are going to be behind our decimal. So our final answer will be 23 and 46 hundredths. Okay, let's look at B. We have 3 times 16 thousandths. So we're going to multiply just like their whole numbers. So we'll put 0, 0, 1, 6 on top since it has more digits, times 3 on the bottom. 3 times 6 is 18. Carry the 1. 3 times 1 is 3, plus 1 is 4. 3 times 0 is 0. 3 times 0 is 0. Now we need to count the number of digits behind our decimal place in our problem. Well, we have 1, 2, 3, and then 0 over here, so we have 3, so we need 1, 2, 3 behind it over here. So your answer is 48 thousandths. Okay, let's keep doing some more example problems. We have multiply 4 and 8 tenths times 3. We will pretend like it's a whole number, 48 times 3. 3 times 8 is 24, carry your 2. 3 times 4 is 12, plus 2 is 14. We have 1 digit behind our decimal point in our problem, so we're going to have 1 in our answer. So 14 and 4 tenths is our answer. And here we have 0.0045 times 5. So let's pretend like there is no decimal point. 5 times 5 is 25. Carry your 2. 5 times 4 is 20, plus 2 is 22. 5 times 0 is 0, plus 2 is 2. 5 times 0 is 0. 5 times 0 is 0. And we have 1, 2, 3, 4 numbers behind our decimal point in our problem. So we're going to have 1, 2, 3, 4 behind it in our answer. So our final answer would be 0.0225. And we can put that in a box. Okay, let's move to example 2. Example 2 is using mental math. So here we're going to teach you a shortcut, a little trick that you can use to avoid having to use the standard logarithm. When multiplying by a power of 10, we can use mental math. We can do that by counting the number of zeros and moving the decimal point that many places to the right. So for example, if you get a problem that says 1 and 35 hundredths times 100, you do not need to do any math here. You can take a shortcut. There are 2 zeros in 100, so we are going to move the decimal point in 1 and 35 hundredths 2 places to the right. So we have 1 and 35 hundredths. We're going to move it 1, 2 places, so our final answer would be 135. Alrighty, and let's do the example from the video together. We have 3 thousandths times 10. Well, there is 1 0 in 10, so we are going to move our decimal point 1 place to the right. So our final answer becomes 3 hundredths. Alrighty, let's move to page 12 and move on to another key idea. This key idea says, when multiplying decimals by decimals, multiply as you would with whole numbers. Then add the number of digits behind the decimal in both factors in your problem, and the sum of the number of digits that should be behind the decimal point in your answer. So we are really not doing anything different here. We just have to count more places that are behind our decimal point or to the right of our decimal point. So let's look at example 3. It says 4 and 8 tenths times 7 and 2 tenths. So we're going to multiply as we would with whole numbers. So we have 48 times 72. 2 times 8 is 16, carry the 1. 2 times 4 is 8, plus 1 is 9. Add in your 0, which is your placeholder. 7 times 8 is 56, carry your 5. 4 times 7 is 28, plus 5 is 33. Then we will add like normal. 6 plus 0 is 6, 9 plus 6 is 15, carry your 1, 1 plus 3 is 4, and 3 there. So we have 3, 4, 5, 6. Now we need to determine where to put our decimal point. Well, if we look in our problem, we have 1 number to the right of the decimal point in this problem and 1 over here in this factor. So we have 2 total. So 1, 2, we'll put it right in between there. So you have 34 and 56 hundredths as your final answer. Okay, for B, we have 3 and 1 tenths times 5 hundredths. So you have 31 times 5. 5 times 1 is 5. 5 times 3 is 15. So we have 1, 2, 3 numbers that are to the right of our decimal point. So we need 1, 2, 3 to the right. We can add a 0 in front, and our final answer is 155 thousandths. All right, let's do this example from the video together. We have 2 and 7 tenths times 9 and 4 hundredths. Multiply like whole numbers. So we can pretend it's 904 times 27. And I'm going to rewrite that because I'm not going to have enough room. Let's retry. 904 times 27. There, that looks much better. 7 times 4 is 28. 7 times 0 is 0, plus 2 is 2. 9 times 7 is 63. 2 times 4 is 8. 2 times 0 is 0. 2 times 9 is 18. Okay, I'm going to rewrite that up here so that we can add much easier. 8 plus 0 is 8. 8 plus 2 is 10. Carry. 3 plus 1 is 4. 8 plus 6 is 14. Plus 1 is 2. So you have 2, 4, 4, 0, 8. And we need to determine where to put our decimal. We have 1, 2, 3 numbers to the right of our decimal point here. So 1, 2, 3. So we get 24 and 408 thousandths as our answer there. Okay, real life application. You buy 2.75 pounds of tomatoes, which cost $1.89 per pound. You hand the cashier a $10 bill. How much change will you receive? So we need to find the cost of the tomatoes first by multiplying $1.89 times 2 and 75 hundredths. So we can pretend like these are whole numbers and multiply. 5 times 9 is 45. 5 times 8 is 40. Plus 4 more is 44. 5 times 1 is 5. Plus 4 is 9. Placeholder 7 times 9 is 63. Carry. 7 times 8 is 56. Plus 6 would be 62. 7 times 1 is 7. Plus 6 is 13. Now we need 2 placeholder zeros. 2 times 9 is 18. Carry your 1. 2 times 8 is 16, plus 1 is 17. 2 times 1 is 2, plus 1 is 3. Okay, and I'm going to rewrite that over here so that we have more room. Okay. Let's go ahead and add that up. 5 plus 0 is 5. 4 plus 3 is 7. 8 plus 2 is 10. Plus 9 is 19. Carry the 1. 7 plus 3 is 10. Plus 1 is 11. Carry. 3 plus 1 is 5. Okay. So now we need to determine where our decimal place is going to go. Well, in our problem, we have 1, 2, 3, 4 numbers to the right of our decimal point. So we're going to have 4 in our answer. 1, 2, 3, 4. So we have 5.1975. Okay, so we need to round because when you're talking about money, you can't have that odd number. So 5.1975 would round to $5.20. But we are not done here because the question asked, how much change will you receive? Well, since we paid with a $10 bill, we will need to do 10 minus $5.20. Add in a 0. When we borrow, 10 minus 2 is 8. 9 minus 5 is 4. So the change that we would get would be $4.80. Okay. For your independent practice, I'd like you to do 1, 2, 3, and 4, and we will check those together in class.